All right, here we go. This lesson is about solving linear equations. And you should take a few minutes to read through this page, read the objectives, the vocabulary, and what it means to be a linear equation in one variable, and then the strategy for solving, and then what it means to have no solution or infinite solutions. And we'll talk about that further as we get further down into this video. All right, so the first thing we want to talk about is just distributing and combining like terms. So if you read through the strategy, it talks about eliminating fractions, eliminating decimals, and we only want to do that if we have fractions or decimals. So if we don't, we just go right into doing distributing, combining like terms, getting variables on one side and numbers on the other, and then solving and checking our work. Okay, so in this case, there are no fractions, there's no decimals, so we're going to go right into distributing because I see parentheses with a number outside the parentheses. So I'm going to distribute the 4 to the 2x and the negative 3. So I have 8x minus 12 plus 7 equals 3x plus 5. And then we can do some combining of like terms. So we've got some like terms here. So negative 12 plus 7 is negative 5, so we have 8x minus 5 equals 3x plus 5. And whenever we now want to get the variables on one side and the numbers on the other, we always start with the smallest variable. So in this case, the smallest variable is 3x, so we're going to subtract 3x. And we're going to end up with a bunch of 5s. So we end up with 5x minus 5 is equal to 5. Okay, and then we want to get the numbers on the right-hand side. So when I say numbers, I mean any number that doesn't have a variable attached to it. So in this case, the negative 5, so we're going to add 5 to both sides. So we have 5x is equal to 10. And then it's pretty straightforward to divide by 5 and know that x is equal to 2. Okay, but what we should get into the habit of doing is checking our work, because we want to make sure we know we have the right answer. So I'm going to check my work by plugging that answer into the original equation. So I'm going to say 4 times, and we're going to have a bunch of parentheses. It might get a little sloppy, but that's okay. 2 times 2. If you wanted to use brackets here instead of parentheses, you could. But if you can keep track of parentheses, multiple sets of parentheses, that's perfectly fine. Okay, so we have plus 7 equals 3 times 2 plus 5. Okay, and so I'm just going to simplify as much as I can here, and I'm going to do several steps at once just because I think you're capable of doing that. So inside these parentheses here, 2 times 2 is 4, 4 minus 3 is 1, and 4 times 1 is 4. So we have 4 plus 7 is equal to 6 plus 5. And then if we add those together, we get 11 is equal to 11. And if you remember from intermediate algebra, if we have the same number when we substitute our answer for the variable on either side of the equal sign, then we know we have the right answer. So I'm confident that the x equals 2 is correct. Okay, let's look at another example with distributing. Okay, so we're going to distribute this 8 to the 2 and the negative t. So we have 16 minus 8t plus t equals negative 4t. Okay, so we're going to combine like terms here. So we have negative 8t and positive 1t. So we have 16 minus 7t. Be careful, that sounds like 70. It's 7t equals negative 4t. Okay, and then I'm going to move the negative 7t because it's smaller than the negative 4t. Some of you might be like, hey, wait a minute, 7's bigger than 4. Well, but remember, negative 7 is smaller than negative 4. So I'm going to add 7t to both sides. And when I do, I get 16 equals 3t. Uh-oh, we're going to get a fraction. Everybody's favorite. Here we go. So we have to divide by 3. So we end up with 16 thirds is equal to t. Now, in a previous lesson, I would have said, hey, let's turn that into a mixed number. So we would divide 16 by 3, and we'd get 5 1/3. But we can't substitute 5 1/3 into t very easily. So what we have to do is try to substitute 16 thirds into t. So we're going to say, all right, we have 8 times 2 minus 16 thirds plus 16 thirds equals -4 times 16 thirds. Oof, this is going to be fun. All right. How should we do this? Well, we need to get a common denominator, right? So we need to say 8 times, and to make 2 into a common denominator, we're going to say 2 over 1, but then we're going to multiply it by 3 over 3 because we want our common denominator to be 3, so we end up with 6 thirds minus 16 thirds plus 16 thirds equals, and I can do the math here, this is -64 thirds. Okay, so let's keep going. We're going to simplify what's in the parentheses. So we have 8 times -10 thirds plus 16 thirds equals -64 thirds. And then we need to multiply that 8 times the -10 thirds, so that's -80 thirds plus 16 thirds equals -64 thirds. And then when we combine these two on the left-hand side, we get -64 thirds. Look at that. It worked. So that's quite a bit of trouble, right? But I guess it feels good to know that 16 thirds is the correct answer, and especially when we get a weird fraction like that, because we're so used to getting numbers for our answers that are nice, neat whole numbers, or maybe something with a decimal of 0.5. But when we get 16 thirds, that makes us kind of say, I'm not sure if that's right, but we've just shown that it is. Okay, so I know it's a lot of work, but I would get into the habit of doing that. Okay, so the next thing we want to talk about is eliminating fractions. And this has always been kind of a tricky little thing for some people. So I see several fractions here. I see 2 actually. So in that first term, remember x over 2 is the same as 1/2 x. Okay, so we have a 1/2, and then we have a 2/3, and then we have 2 whole numbers. We have a -1 and a -3. But what I'm going to do to eliminate the fractions is I'm going to multiply this entire problem by the least common denominator of the 2 denominators. So when I say that, if I have 2 and a 3 for my denominators, the easiest way to find the least common denominator is just multiply them together. So if I multiply those together and I get 6, that's my least common denominator. So what I'm going to do is I'm going to distribute a 6 to every single term in this equation. And I'm going to distribute backwards. I hope you're okay with that. So we're going backwards to distribute, primarily because I just didn't have enough room on the left-hand side to put a 6. So when I distribute backwards, what I end up with is, and when I distribute that, I'm only going to multiply by the numerator in the fractions. And then I'm going to multiply by the whole numbers, the -1 and the -3. I don't want to worry about the denominators or the x at all. I'm just going to multiply by the numerators and the whole numbers that are the other terms. Okay, so I have 6x over 2. And you can kind of see what's going to happen there. 6 divided by 2 is 3, right? So we're going to be able to eliminate that fraction because of this. Then we have -6 equals 12 over 3x, because 6 times 2 is 12. And you can see what's going to happen here. We're going to end up with 4 because we're going to divide by 3. and then we have minus 18. Okay, so I already said it, 6x over 2 is the same as 3x, and then we have minus 6, and then 12 over 3, I already said it, it's the same as 4x minus 18. Okay, so now we have a problem with variables on both sides, and we'll just solve it like we know how to solve it. So we don't need to combine like terms, we don't need to distribute anymore, so we're just going to move the variables on one side, the numbers on the other, and in this case I'm starting with the 3x because it's smaller than 4x. So I have negative 6 equals, I can just write x because 4 minus 3 is 1, and I don't need the 1. If it were a negative 1, I'd probably put the negative 1 there. But since it's just a positive 1, I'm going to leave it like that because this will make it one less step when we get to the very end. So now I'm going to add 18 to both sides. So I end up with 12 over here and x over here. And just like before, I can check my work. So this is going to be kind of another semi-painful one because we've got fractions we're dealing with. But I'm going to plug in my 12. So I have 12 over 2 minus 1 is equal to 2/3 times 12 minus 3. Okay, so this is where we can kind of be a little bit creative. So 12 over 2 is 6, right? And 6 minus 1 is 5. So I'm just going to write that as a 5. And then 2/3 times 12. So if we remember back to when we learned about multiplying fractions by numbers, the numerator multiplies, the denominator divides. So we have 2 times 12 is 24. 24 divided by 3 is 8. So we have 8 minus 3, and 8 minus 3 is 5. So we end up with 5 is equal to 5. So I can be confident that my 12 is the correct answer. All right, let's keep rolling. So another example of eliminating fractions. In this case, we only have one fraction. Even though we have kind of a big old mess in the numerator, this is still just one fraction. So I only have one number to find the least common denominator, so I'm just going to multiply everything by a 3. Okay, so this one has provided a fair amount of confusion in the past because when people distribute the 3 to here, it's pretty simple. It's 3 times 2, right? And to here, it's not bad. It's 3 times 6. But then to here, they're like, do I distribute to that 3, to the A, or to the 2? Well, the answer is to the 2. So we're going to distribute to that 2 and not distribute to the A and the 3. Okay? So we're going to go ahead and do that. So we end up with 3 times 2 is 6. So we have 6A plus 3 over 3 equals 18A plus 6. All right. So maybe a little explanation is needed. When we have that 2 and then multiplied by something in parentheses, we can really look at it like this. Let's say we have 2 times A plus 3, right? And we're distributing a 3 to it, so we're multiplying it by 3. We're multiplying this whole thing by 3, right? Well, that A plus 3 is very similar to an x in something else, so it would be very similar to multiplying by 2x. Well, when we multiply it by 2x, we don't multiply the 3 by the x and the 2, we just multiply it by the 2. And the reason is because between the 2 and the x is multiplication. And between the 2 and the A plus 3 is multiplication. So that's why we only multiply this 3 by the 2 over here and not by the two things that are inside the parentheses. Okay, I hope that helped. Let's keep going. So now when we simplify this for the same reason that I just went through, when we simplify, we can take the 6 and just divide it by 3, and we end up with 2 times A plus 3. And then we have 18A plus 6 on this side. Okay, so then, boy, we got a lot to do here. So we've got more distributing to do. So we have 2A plus 6 equals 18A plus 6. And then what we're going to do is, now with this one, I don't know if some of you can already see what the answer has to be, but I'm going to keep going through this. We're going to subtract 2a from both sides. So we end up with 6 is equal to 16a plus 6. Anybody see it now? If we think about it, if we're adding something to 6 and it's equal to 6, the only thing that we can add to 6 to make it equal to 6 is 0. The only way we can turn 16 into 0 is if a, whoops, that didn't work, is if a is equal to 0. Okay, so we know that a is equal to 0 because that's the only thing that we can plug in here to make 6 equal to 6 and adding something to it. All right, so a being 0 makes checking our work fairly straightforward, because if we go up to this and we say, all right, 2 times 0 plus 3 divided by 3 equals, well, 6 times a is 0, right? So this is, we're just going to have a 2 on the right-hand side because the 6a equals 0, right? So then the 2 times 3 divided by 3 is equal to 2. Well, these 3's just cancel each other out, so 2 is equal to 2. So there we go. We know we have the right answer. All right. Let's see. We've got like 3 more left. Let's do it. Oh, decimals. Okay, so decimals. Really hard to work with if we're solving equations. I know some of you are going to try. You're going to distribute this 0.1 to the x and the 3, and then you're going to multiply the 22 by 0.05, and it's just going to be like head scratching, because it's like there's going to be so many decimals and so many numbers. It's really hard to understand how they relate to each other. So there is a way that we can eliminate all of the decimals, and it's simply by multiplying by a number like 10 or 100 or 1,000 or 10,000. It just depends on how many decimal places we have. So in this case, we have 2 decimal places in each one of these decimals, and each term begins with a decimal, right? So we have a decimal here, we have a decimal here, and we have a decimal here. So if each term has a decimal in it, we can eliminate all those decimals by multiplying by 100, because there are 2 decimal places in each one. All right, so if we distribute a 100 to each one of these terms, now remember, when we distribute to that second term on the left-hand side, we're only distributing to the 0.10. We're not going to distribute to the x minus 3. Same thing on the right-hand side. We're not distributing to the 22, just the 0.05. All right, so when we multiply 0.25 times 100, it changes the 0.25 to 25. So this becomes 25x. And then this, instead of being 0.10, this becomes 10. And instead of being 0.05, this becomes 5. All right, so we just eliminated the decimals by multiplying this entire equation by 100. Okay, and so now it's going to be easier for us to do the solving because we don't have those decimals to get in the way. All right, so the first thing we're going to do is distribute here. So we have 25x plus 10x minus 30 equals 5 times 22 is 110. Okay, so then back to our little strategy. We're going to combine like terms next after we distribute. Now, you don't always have to combine like terms after you distribute, but sometimes, in this case, we do. So we have 25 and 10x, so that's 35x minus 30 equals 110. And then I'll add 30 to both sides. So 35x equals 140. And you might be looking at that thinking, oh, I don't know if 35 goes into 140, but 35 times 2 is 70. 70 is half of 140, so it's going to go in there. So x is equal to 4. Okay, I am going to forego checking my work on this one because I'm confident that the 4 is right. If you want to check my work, feel free to do it. That would be a good experience for you to do. So let's look at another one. I think we got another decimal. No, we don't. So the next two are about no solution or infinite solutions. So far, we've had one answer for every one of our problems that we've done. And that's fairly normal. We're hopefully going to get one answer for our problems when we're solving a linear equation in one variable. But in this case, we are going to do something here, and we're going to see that we're going to have some trouble with this one. So let's just do it. So I see some parentheses with a number, so I'm going to distribute. Well, that's not what I wanted. Distribute. So we have 3x minus 12 equals 3x minus 12. Notice anything? Both sides are exactly the same. If both sides are exactly the same, that means I can plug any number in for x on the left-hand side, and I'm going to get a number of some sort. And if I plug that same number into x on the right-hand side, I'm going to get the same number. So what this means is I can plug in any value of x into this equation, and I am going to get a solution of some sort. Okay, so what that means is this problem has infinite solutions. So I just have to write infinite solutions. Okay, and the key thing to look for is identical expressions on both sides of the equal sign. Okay, so in this case, 3x minus 12 is the same as 3x minus 12. So that means that we have infinite solutions to this problem. Okay? All right, let's look at another one. So here we go. This is kind of big and crazy looking, but let's go through this. So we've got to distribute twice here. We're distributing here and here. Ooh, we're going to distribute twice. We're going to combine like terms on both sides. We got a bunch to do. So we have negative 2x plus 10 plus another 10 equals negative 3x minus 6 plus x. All right, let's combine like terms. So we've got some 10s there to combine on that side, and we've got a negative 3x and a positive x to combine here. So I use the same color of highlighter. Maybe I shouldn't have. We're not going to combine all these together. We're going to stick to one side of the equal sign and the other. So we have negative 2x plus 20 equals negative 2x minus 6. All right. You can maybe kind of see where this is going. We have a negative 2x and a negative 2x, but on the left-hand side we're adding 20, and on the right-hand side we're subtracting 6. So no matter what, the negative 2x is going to be the same no matter what number we plug in there, but when we add 20, it's going to be one thing on the left-hand side, and when we subtract 6, it's going to be another thing on the right-hand side. So let's keep going. Let's move our variables. So in this case, they're identical. So we can't start with the smaller one because if they're the same, they're both the same size. So we're just going to add 2x. I guess what I was trying to say is it doesn't matter which one we start with because they're the same. So when we do this, we get some canceling of that and canceling of that, but our x went away. And when our x completely disappears and we end up with something like 20 equals negative 6, and we know that this is not true, So because this is not true, if we can eliminate our variables like that when we're solving an equation, and we end up with something that is not true, we have to say this problem has no solution. Okay. All right, so this was probably a bit deeper than you've taken solving equations in the past in intermediate algebra. So that's kind of the point about Algebra 2, is we're going to challenge you a little bit more to take things a little bit further and understand the concepts a little bit further. So what I want you to do is, if you need to, go back and rewatch things in this video. But try the assignment. There's very similar problems on the assignment to what we just did. So if you run into one on the assignment and you're like, I'm not sure, come back and look at parts of the video again if you need to. But do that assignment, save it as a PDF, upload it to Schoology so I can take a look at it and give you some feedback on it.